Hey guys, welcome back to the next video. In this video, we will talk about removing all these things with the hierarchy. So kubectl delete first remove the deployment, which you have done. Deploy slash NFS deployment. Don't remove the provisioner. Remove only the NFS deployment. Once the NFS deployment has been removed, then you can remove the PVC. This should remove your all right, so you can now remove your PV as well. Now you can remove your storage class as well. Storage class removal, it's not that required to remove the storage class because there's not much configuration on your storage class. But still, we will remove it. Why? Because we have other storage class which with different options which we're gonna use. So yeah, so let's just have that removed as well. Yeah, sounds good. So now let's go to storage folder. Under the OPE software folder, create a folder called P14. Let's get inside this P14 folder and then just start working with this CD P14. I don't know what I'm doing. All right, so that's done. So let's go back to your P14 in your advanced class over there. So what we're gonna do right now is like we are going to create two storage classes, and these storage classes are one for web and one for app. Okay, so we're gonna use these two storage classes for the same. So let's just go ahead and do that. So first one is going to be VI storage class 2. In this, we are going to create the web one. So I'm gonna name this as web storage class, as you can see. And this is going to use the same, sub external provisioner, the provisioner name. And here the reclaim policy is delete. And here the parameter is archive on delete is true. So it's going to archive the data when it's when the PVC is removed. And you can see allow volume expansion is also mentioned as true. But do remember that volume expansion only supports on a specific devices. I'm not really sure it would work here. So create the storage class 3. In this file, we are going to create a storage class for app. So just copy paste it. So this is going to be app storage class over here. And this has the same provision name. And here allow expansion is true. And here reclaim policy is going to be retained. So save and quit this file. Now, before we proceed with any further, go to MNT NFS and remove that default folder because it will avoid confusion. So just remove that one over here. So the next file which we are going to create is your PVC6, which is going to be a PVC related configuration. So now just go ahead, edit that file, copy paste the content. Now I'm becoming very stingy, so I have given only 5 MB over here. I just want to give you another option here, so I'm just giving only 5 MB of a web storage class size over here, and the read access mode is read write many, and you can see this is named as web PVC. So this just will create a difference when you are looking at the folder name. Save and quit this file, and you see that the storage class name is also web-storage class. So now create another PVC. This is for your application. And that's going to be copy pasted, and that's going to be a little generous. 50 MB of a file size. I'm not really sure what's the size of my application. So let's just do an SFNLTR on MNT NFS app. This is 54 MB, right? So let's make that 100 MB. Oh, all right. So now, actually, it should at least, I should be able to copy the file at least. Right. So now here, the same thing, app storage class and app PVC is the name of it, and read write many. All right. So now let's go ahead and configure our pod 12. Which is over here and just do copy paste it. It's a lot of lines of coding, but don't worry, it's not something new. We have already discussed all those things. So let's just go over here. So let me expand this a bit so it must be faster. Let's go from the beginning. Deployment, it's kind, and the name of is Sterling deployment, and number of replicas too. And it has like app, which is a Sterling app, and it has the environment labels like app name, environment name, type, version. And then here we are using OS container as alpha and image. So here we are inserting date and host name into this. And here we are using web path, web volume, which is going to be slash where HTML. So we have multiple volumes, which we will see on the end. One is web volume and app volume. I've kept it very simple. And here, this is readiness probe, nothing much to examine here. This is the Nginx container, web volume. So this is, both should be on web volume because it is writing the web data, right? So index.html. So it will be web volume and it is getting mounted on this HTML path. Then AD folder, it's a liveness probe and readiness probe. See, this is what I wanted to do. So this is 8080, right? Yeah, so liveness probe, readiness probe is also part of this, and 8080 is the port number, and Tomcat latest image, and app volume is mounted on user local Tomcat web apps where my application will be there. And here I have the web volume, app volume, that's the definition, and this goes to web PVC, and app volume goes to app PVC. So that's basically where my PVC is getting declared. And this is the service. Basically, you can use the 80 port number for browsing the 80 service. Don't ask me where is the service for 8080. I have not configured it. I have not thought about it actually. But you can create another service for your 8080 port number as well. You can copy paste the same thing, create a different name for your service and put 8080 there. So you can take this as homework. Save this. So that's pretty much it. Let's see how many errors we get. So let's go about executing one by one. Sorry, kubectl apply -f. The first one is about classes. Class 2 is created. Storage class 2 is created. Class 3 should be created. PVC 6. PVC 7. Let's see if it's getting attached. No space. Is it bounded? Yeah, it's both are bounded. One is on return, one is on delete. One is app PVC, web PVC. And that's the one over here. There's a PV which is created. There's a storage class which we created. So it's all like good so far. So one is 5 MB, one is 100 MB. It's amazing. Rewrite many. All right, so let's just, we have done half of the work. kubectl apply fnf. The one last pending file is pod 12. Let's see about this. What? So it says like not found web volume. Why? It says service is created. kubectl delete. Let's remove the service. Let's just go ahead and examine this file. I'll pause the video and pause it once I understand the problem. I think I fixed it. The problem is that there were a couple of problems. I did run some check. The Tomcat put number is not working, so I removed from Tomcat the readiness and liveness check because we need to customize it more for Tomcat, the readiness and liveness. I don't really have the time for it. So what has happened is I defined volume 2 times. So I shouldn't be doing that. I just put both the volumes in the same. That's the thing. When I copy pasted it, I guess I did copy the volume one more time as well. So I've got that corrected for you on the documents as well. So you should be good enough to copy paste it now. It should work, and it should be exactly like this. So let's go ahead and run kube ctl apply fnf. You can see that it is deployed now. So let's see if these containers are coming up. Let's just do kube ctl describe. Let's just go and check for errors beforehand. There's no errors at this moment, so it is all like working fine. So the 3 containers are running now. So it's 1 out of 1, 2 out of 3. Sorry, 1 out of 3, 2 out of 3. And the last one should be updated anytime now. 3 out of 3. So there you go. The deployment is successful. You have the Nginx service as well. You can create one for Tomcat as well. That's not a problem. So now that there's no errors, right? So what I'm going to do right now is basically I'm going to MNT NFS. Firstly, I'm going to curl and see if this Nginx service is automatically writing data. Seems like a port number is not working for it. So it says like connection refused. That's weird. That's weird. All right, let's try accessing the individual IP address, see what it says. So this one over here. Oh, all right, individual IP works. Yeah, individual IP works, but not sure why node port is not working. Maybe I need to reconfigure it because if you remember this node port, right, it was saying that it is changed, unchanged. So maybe this is not reflecting the right endpoints. It is reflecting old endpoints. Maybe that could be the reason. So if you just do kube describe, kube control describe, and this one over here, I'm pretty sure it is going to, okay, you can see the endpoints is nothing. So we may have to do this kube ctl delete, and then run the deploy apply again. So this will create it. Yeah, so now this should work. Cool. Huh, still the same error. Let's look at the endpoints. Oh, sorry. We're not supposed to do that, but let's just verify this file once. See if this file is correct. It's looking for NFS app. Oh, okay, correct. The name of the app is changed, I guess. So we just need to look for the label name here for Nginx. So for this pod. This pod is Sterling app. So that's the one. That's the problem. There you go. Now let's just apply this file to describe the service. There you go. Endpoints are coming up now. Nice and clear. So yeah, there you go. IP address is also working fine. That's amazing. So I'll get that sorted for you as well in your file. This is looking for Sterling. All right, it's all sorted now in your file. So there you go. So now your IP address is working. Now let's just check for Tomcat. Tomcat wouldn't be working because there is nothing there. There's nothing deployed. So you have to go to MNTNFS. So now in this, you see 2 folders. One is the web folder. As you know, web folder is already updating with the file size. You can see that this is the index.html is getting updated with the data over here. That's automated by updating from your your Alpine operating system. And the app folder should be nothing. There should be nothing in here. So what I'm going to do is there is application here. There's a demo application, 1 folder back. So I'll pass it on to you as well. So just copy this application. So I just need to do ch own 666 to this file. Oh, it's already deployed it. Now you see that? So the Tomcat deploy it. So you see that already it has deployed it. it has created a folder, so that's good. So I don't do that. I just copy the WAR file. So if I'm gonna type call this IP address colon 8080/IVR, this is how you need to type an application. Well, nothing happened. Oh, there you go. There's some output here, so you can see that there's some output over here. So this is coming from 8080 of this IP address, so you can try with the load balancer as well. So this is basically this one over here, so you can see that. Oh yeah, of course the load balancer is configured for 80 port number, not 8080, right? So obviously it won't work. So why don't we make it work then? Just go OPD software. It's not too late now because we're already here almost. So let's open the same pod 12 file. Let's create another service here. Let's just minimize this. So let's copy these lines. I guess it will be 30 lines, right? 30 YY. So it's called yonking. So paste it. So it's basically giving escape. Just type 30 YY. It's gonna yonk 30 lines from the bottom, and then just give P to paste it. So here is the port number. The port number of the service I wanted to be 8080. I want the target port to be 8080 again. The node port number is going to be 30,001, so that I can browse this application. Let's just apply this. kubectl apply -f. Now this service is created. Oh, the bad thing is I created with the same name. That's weird, right? Yeah, I guess I override it. So we're just gonna do this one service one, so that I have the 80 port number as well. All right, there you go. So what I'm gonna do is like I'm gonna use the local IP here and then try to browse it. Yeah, sorry. I didn't want to see my URLs list, so that's why I paused the video. 30,001/IVR is the application name. So let's see if this works. There you go. Your application works fine. And you can see that this is the application coming from your 10.0.15.139, which is basically the system master server. And then the 30,001 goes to your Tomcat, and that you're able to see the application over here. Amazing. So you were able to deploy two different applications within your one pod, one deployment. Sorry, 3 containers are running, and it's all it's divided into across two volumes, and these 2 volumes are working towards getting you that update. So here I can also create another file over here, touch index.html, just to show you that this is where we are getting from. Test. Control D. So let's just go over here and type index.html. Not found. That's weird. So index.html, ch own, nobody. Yeah, so let's try it now. All right, so it's not working. Yeah, there you go, index.html. That's the default page. So you can see that right now it's working. So you can type calendar or HTML. That's basically the file over here. So that is what I want to show you on this video, on a real-time situation where you have multiple storages, because that's how we have configured in our environment. So it's just more easy for me to show you that, because this is what it happens in a banking or in a retail environment where there's just so many transactions happening. So more or less in our environment, we use AWS. Sometimes we use Azure as well. Depends on the company. So yeah, so this is basically how it is done. Thank you again for watching this video. I'll see you on the next one.